Hey guys, Bobby Thompson back with another video, and in this video I want to talk about what are the odds. What are the odds that we observe and experience so many statistical impossibilities in this realm we live in, right? With the mainstream explanation, the heliocentric explanation, and taking another look at it from the flat Earth perspective. Let's look at some of these occurrences. So we'll start with the universal plane. That's what I called it. Our universe is flat. This is just from a Google search. If you're not familiar, you can research the shape of our universe. And this is right from nasa.gov, Universe 101. And it talks about the shape of the universe, and says if the density of the universe exactly equals the critical density, then the geometry of the universe is flat like a sheet of paper and infinite in extent. And this is the shape we believe the universe is, right? Or mainstream science believes. And you can pause this, read further. As of 2013. We know with a 0.4% margin of error that the universe is flat. So basically, they're saying 99.6%. They're sure. Mainstream scientists believes we live essentially in what's equivalent to a sheet of paper. Okay, so that's our. So there was this explosion in a vacuum. Nobody knows why. There was just this explosion. All matter went shooting out in the shape of a piece of paper. I don't know, sounds odd to me, but let's just go a step further. Our solar system is also flat. So if you weren't aware of that, all of the planets that supposedly circle the sun in this heliocentric model do so on the same plane, with the exception of comets. Comets, ironically, inexplicably, circle perpendicular to that, right? So you could see this obviously isn't to scale. It's just something showing that we have all these orbits of all the planets, and they are on the same plane. With the exception, and these are asteroids out here. This is an asteroid belt. Everything's on the same plane except for comets. Comets obviously go perpendicular to that. And while we're talking about comets, let's look at Halley's Comet, right? Because this is another statistical impossibility to me. You know, I can understand an orbit. If you say I have a magnet, and if I swing something by a magnet and it just catches around that magnet just right, it would orbit the magnet, right? If you skim too far away, it just kind of changes the angle of it. It goes off at a different angle, and if you go too close, it whips into it, right? Like it would, like kind of like a black hole. It would just connect to it. And I could imagine, I could buy off into science saying, oh well, if you get it just perfect, right? Like I can understand people buying off into that. Although in reality, you would eventually get sucked in. There's no way you could get caught and just perpetually stay swinging around something, right? Like this is something we can't observe in a lab or on Earth. It's something we can only ascribe to in science, right? We can only say, well, our solar system works like that, right? Because you have to make up explanations for this. But how do you explain Halley's Comet or other comets, right? Halley's Comet comes around every 75 years. It swings into, and these are millions of miles, by the way. It swings around the sun, and then it's leaving. It's gone. It's like, I'm going completely different direction. It's like I didn't quite make the orbit these other ones did. I'm gone, right? Millions of miles. 15, 20 years later, it changes. It's like, oh, you know what? I think I feel the sun tugging on me. Oh, yeah, it just swings around that corner. How do you get an ellipse like this, right? And it's way more, this is a condensed version of it. Like you have to imagine this is the distance this comet would travel to come back around. And that's how they have to rectify this, in my opinion, right? It's the only way you can justify the heliocentric model with the observations that we have. The flat Earth model, to me, is much simpler. And just, adding a little context to it, every 75 years we can observe Halley's Comet swinging back around by the sun. Makes no sense. And this is that flat plane, the solar plane, if you will, right? That's just a term I used for it, right? So all of these planets, if you notice something, they're all on, the same plane. It's cocked at an angle, but it's going through space. So here's space. Space is a flat piece of paper, okay? And the solar system is traveling through this flat piece of paper like this, right? Like that's the planets going around the sun. But at an angle, cocked at an angle. But none of the planets are trailing the sun. They're level with the sun. It's, at the bottom side of it, looking at it from the side, right? If we're, somehow cosmically looking at it from the side, they're trailing briefly, but then they're leading. They're on the same plane. It's at an angle. How does that happen? How does the sun pull something? I mean, and is that how orbital mechanics work? That's not orbital mechanics. If I'm swinging a yo-yo and I pull it as I'm swinging it, the yo-yo is going to be behind it, right? Like this makes no sense. If you can justify that, great, but none of mainstream science is repeatable or observable on Earth, or very little of it, in my opinion. Let's look at star trails, though. This is what happens when we do a time lapse at the North Star, the pole star Polaris, right? All of the stars move in perfectly concentric circles. This is the firmament rotating, right? I never knew that before I got into flat Earth. I didn't know the sky turned like a record above us, right? The wheel in the sky keeps on turning, right? So many things make sense when later, when you go back and look at all these songs and references you never made connections with. But I don't know why this is in such a low resolution here, but this is the firmament. And again, I apologize for the resolution, but this is what we see. We see all the stars locked together with no observable parallax, right? What science calls parallax is a measure of redshift. It's something like if they would change colors, which gases passing in front of something can change colors, right? That to me is just BS science. There's no actual measurable movement between the stars. And if they say there are, no human being can measure it from their yard, right? Or with a telescope. It's always some scientist utilizing data from some telescope in space. And this is how we get star trails. So now let's move on to constellations. Here we have the 12 constellations. And these constellations have never changed as long as humans have recorded, have recorded anything, recorded the sky, right? There has been astronomers, as they might not have been called that, but that's what we call them today. As long as there's been human history. So we've never observed a change in any of these star groupings, right? Here's this 13th century Suzhou star chart, which features traditional Chinese astronomical groupings. And again, this is basically the firmament, and none of these constellations lose their shape. And the first star catalogs on record were produced by Chinese astronomers around 2300 BC. That's like, 4,323 years ago, if I got that right. With Babylonians making the first almanacs as early as 750 BC. Like how crazy is that? 4,300 years ago, we were recording the stars, and there's no proof that they've ever moved as long as we've been recording them. The sun, what are the odds that, this is the sun through a solar filter. Forget NASA CGI. This is what regular people see when they use a solar filter on a high-powered camera like a P900 or P1000. We see a disc. I would call this a disc, right? It has smooth edges. Like they're saying this is a fireball in space. If you believe that's a ball of fire and it's perfect, right? I guess you can. That's great. Gravity fixes all things. It just makes perfectly perfect. Again, I can't stress perfect enough. It makes it this is a perfect sphere. And okay, you want to say fire? Well, fire just does that. But what shapes the moon into a perfect sphere? Like there's no abrasion in space. It's a frictionless environment. It's the most frictionless environment we can dream up. It's the most frictionless environment we can imagine, right? So what are the odds that it's just a perfect sphere? And what are the odds that we've only ever seen one side of it? That's why you have a dark side of the moon, right? We've never seen anything but this one side. As long as we've recorded the moon, it's never changed. It just happens to be in perfect sync with the rotation of the Earth, according to mainstream science. And, what are the odds that the sun is 400 times larger than the moon and 400 times farther away? Because that's how you appear to have the same size, right? Every time you double something's distance, it cuts in half. The size of it cuts in half. So we have this perfect, this is called an annular solar eclipse. And you get this perfect, these are two perfect spheres, the moon blocking the sun here. What are the odds of that? What are the odds they meet up absolutely perfect? Here's another annular eclipse. What are the odds, right? But not all eclipses are. There's like three or four kinds, depending on whether you're talking about solar eclipses or lunar eclipses. But why aren't all eclipses, full eclipses, annular? Why is it sometimes there's a ring around it and sometimes there's not? If the sun is 93 million miles away and the moon is roughly, it has an apogee and perigee, but it's roughly 235,000 miles away. How is it? Why does sometimes it line up to block the entire view of the sun, but sometimes it doesn't? It's a little bit as if the moon was farther away enough that we could see the ring, if you will, a halo of the sun, right? It's not moving that much. I don't care if you have a sun that's 93 million miles away. The distance the moon supposedly moves in and out on its orbit around the Earth is minuscule compared to 93 million miles, right? But if you want to believe that. With records stretching back to about 700 BC, Mesopotamians were able to determine the length of Saros cycle. So you'll hear all the time people saying, "Oh, NASA, how can flat earthers predict eclipses?" Well, all of the, whether it's the return of comets or whether it's eclipses happen on something called a Saros cycle. And we were predicting these, human beings, 700 BC, right? That probably sooner, right? Just because we haven't found record of it yet. I mean, as we have more archaeological finds, maybe one day we'll find proof for 2000 BC. But as for now, 700 BC, we were aware of these cycles, right? It's just a cycle. You can read about a Saros cycle. You can read a cycle happens every 18 years and 10 days. The Earth was flat back then. There were no proponents of globe earthers. It didn't require, they were already doing trigonometry. They were already doing advanced math, right? Our ancestors weren't stupid. It didn't take a spherical Earth to come up with a Saros cycle. It's just something you record, and the name given to it was a Saros cycle. It's just a matter of recording these cycles. Now, this is my favorite, right? And to me, it's the most damning. And I call it the celestial clock because the 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 luminaries, the objects, what we observe in the sky, they maintain perfect circuits and perfect symmetry amongst each other, right? And just a couple examples. I kind of want to save the more impressive ones for last, but this is a place called Sri Padmanabha Swami Temple in Kerala, India, and it's estimated at 1,200 years old. And this temple was built, if I understand correctly, on the equator, and there's 2 equinoxes a year, right? I think it's summer and spring equinox, whatever. There's 2 times when the sun crosses over the equator, and you see it set right through each of these openings. These openings are built right through this temple. And you can see the setting sun goes down through each hole. So this was designed 1,200 years ago, and it's a testament that the sun, and well, this one in particular, the sun, but there are other archaeological, buildings that testify to the sun, the moon, the stars, that these things have kept their cycles, it kept their circuits, and they've kept their paths for as long as human history is recorded. Angkor Wat in Cambodia, the spring equinox, estimated 900 years old, but every year, perfectly, the sun right there. Feel free to look it up. Chaco Canyon in New Mexico during the equinox, estimated 1,200 years old, lines up with these holes just like Sri Padmanabha Swami. But this is the most amazing to me, is Konark Sun Temple in Odisha, India. It's estimated 750 years old. I think it's, these estimates are just that, estimates. I don't know that we had records going back to when they were built, but there are 24 of these, if we want to call these dials, going around this temple. And they know that 2 of them can be used, one on each side, one from like sun up until noon, and on the other side from noon until sundown. These are sorry, what's the name for clocks that use the sun for time? Sundials, essentially. These are sundials. And it is accurate to the minute. These little beads going all the way around, each bead represents 3 minutes, but it has the accuracy that it hits the middle of a bead or the left side or the right side of the bead. And if you just put your finger in the center or any instrument, even this here will tell you to like the hour, right? You can look at that, just this protruding out, and look in the middle and roughly know the time. But if you want to be accurate to the minute, just stick something thinner there, and it'll tell you the time on one side up until noon to the minute. To this day, 750 years later, still perfectly accurate, as all sundials are all around the world. And sundials aren't universal, by the way. They work based on their geographic location. If you take a sundial from one location and move it to another, it would need to be recalibrated for that location. This guy does a great video. He talks about, we're not going to watch the whole thing, right? I don't know about the license he has on it. I don't know
Hey
if
guys,
it's a Creative Commons.
I'm going to show you the accuracy of the sundial at Konark Sun Temple in India, built in 1250 AD. People still use it today to tell time. Let me show you a short clip of a tour guide figuring out the time, and then I will explain how the sundial works.
39 12 होने के लिए 39 minutes बाकी है, मतलब 19 minutes. Yes. What is the time?
As you can see, the sundial is pretty accurate and people are amazed by it. Let's take a closer look and see how it works. The sundial has 8 major spokes that divide 24 hours into 8 equal parts, which means that the time between 2 major spokes is 3 hours. There are 8 minor spokes as well. Each minor spoke runs exactly in the middle of two major
So for time reasons, we're not going to watch the whole thing, but if you want to watch this video on YouTube, just search for 750-year-old sundial at Konark, India, Moondial 2. What he realized is and this is a great video. This is amazing that this is accurate.
shows time in an anti-clockwise fashion.
That it's accurate. This was built in 1200 AD, 1200, right? And it's accurate to the minute to this day. Today, we can have, you can take your Swiss watch and go up to it and it's still dead accurate, right? It has 24 of these around it, but only 2 are for day. And they suspect, now, up until 100 years ago, when you listen to him talk about this, nobody knew that these were sundials. Some like monk, or they saw him walking up and using it to tell the time. And that's when they figured out, that happened like 100 years ago, that these, I don't know if a monk's the right word, he talks about it in this video. But they suspect that the other ones, the other 22 wheels are moon dials, right? And they would work off them. The moon keeps the same circuit, and in the right moonlight, you would tell the time with the moon dials. But watch the video. It's a really good video. I know a lot of y'all don't have that much time for this video. This is Sri Siva Yoginathar Temple, Tamil Nadu, India, estimated 1400 years old. And there's a sundial, and it's accurate to this day. It's 1400 years old. It's still accurate to the minute. Feel free to look it up. The Georgia Guidestones, right? They were that was in Elbert County, Georgia. It was had all these, I don't know, the commands of the New World Order, if you will, in 12 languages, and it was blown up in 2022. So, but from 1980 to 2022, there was a hole right here in this center column, and if you look through that hole, it lined up to Polaris. This isn't difficult to do, right? Like, this has been done in many parts of the world where Polaris is in sight. You could just fix whether it be a hole or a point on the pole star, and it'll always be there. This is Anthem Veterans Memorial in Anthem, Arizona. Every November 11th at 11:11 a.m. you get this. Right, you get this this projection on the ground. 11:11 at 11:11. Right, it's that's because the sun keeps its perfect circuit. It's perfectly timed, as is the moon, as is the luminaries, the stars, whatever you want to call them. And this is the most amazing part to me, right? Is that the sun completes one circuit in 86,400 seconds, right? So whether you're a flat earther and you believe it's, going around the surface of above the surface of the flat earth, or whether you're a heliocentrist and you believe that we're going around it, or we're spinning around in one day, we're revolving in one day, 86,400 seconds. And that's a perfect base 60 number, which, by the way, the Sumerians, who told us that we were created by the gods, they said the gods used base 60. This is all, just interesting to me, but our time is based on base 60, right? It's not a base 10, it's a base 60 system. And it just so happens that a day is a perfect base 60 number, 86,400 seconds, right? Based on 60 seconds in a minute, 60 minutes in an hour, and then 24 hours a day. Also, it's all base 60, right? And the most amazing part is that, Google this. How accurate is an atomic clock? It says one of these clocks, the strontium atomic clock, is accurate to within 1/15 billionth of a second per year. This is so accurate that it would not have gained or lost a second if the clock had started running at the dawn of the universe. It doesn't lose 1 second in roughly 14 billion years. Now, what does that mean? That sounds really impressive for the atomic clock, right? Wow. But you know what's more impressive? What's more accurate than the atomic clock? The celestial clock, the sky. Otherwise, just to show you how much BS our government spews, right? And they want you to believe, and that you won't think, right? Because if you have to think, you'd have to say, wait a minute, how do they know how accurate an atomic clock is? What are you going to compare it to? There's only one thing you can compare to. There's only one thing that tells time. Time has always been a measure of where the sun is, right? It's like, as far as time on a daily scale, how would you know how accurate an atomic clock is? You got another atomic clock and you know but how did you know it was accurate, right? The fact that they can tell you an atomic clock is accurate to 1/15 billionth is hilarious. That's the most hilarious science I've ever heard, because it's an admittal to how accurate the celestial clock is. It's saying that that's how perfect that circuit is. If it weren't that perfect, you could never have accuracy like this. Never. They're basically admitting that in 15 billion years, that's how I interpret this, is that it's an admittal that in 15 billion years, our celestial clock wouldn't lose 1 second, right? Because otherwise, what clock is more accurate than our celestial clock? What did you compare the strontium atomic clock to? Do you see the BS that they give you that you don't think about? You wouldn't think about it, but I don't know. To me, that's mind-numbing. Another thing when we're talking about statistics is the dance of the planets. Not all planets. Some of these are, I don't know what Ceres is. I think it's a moon. But Jupiter, Saturn, Uranus, Ceres. Well, and some of these are like, this is Earth and Ceres, Earth and Jupiter, Earth and Saturn, Earth and Uranus, Mars and Ceres, Mars and Jupiter. Read through these, but if you take any celestial bodies, right? Like for me, anything that we see up there besides the sun and the moon are luminaries, right? But, heliocentrists refer to the wandering stars or the wandering luminaries as planets, right? To me, planets are luminaries. But you can take any of these bodies and contrast any two of these bodies or the Earth with any one of these bodies, and you're going to get these perfectly symmetrical patterns, right? And these patterns go on infinitely, as does the perfected circuit of the sun, right? All of these perfectly symmetrical patterns, right? This is not chaos. This is not what you get, right? This isn't entropy. This isn't chaos. This is, this is the opposite of that, right? This is order. This is proof of a God to me. If you can't see that, like perfect time, perfect shapes, perfect symmetry, then I don't know. You're just not meant to see it. These are all just, you can search it on the web, right? You can search for dance of the planets or dance of the stars or symmetry of the planets and symmetry of the stars. You'll find tons and tons of, and YouTube's a great one. Go to YouTube, look at this. Look at some of these, right? The dance of Earth and Jupiter, the dance of Mars and Earth, the Sun, Earth, Mercury, and Jupiter dance, the mesmerizing dance of Jupiter and Mars, Sun, Mercury, Earth, Jupiter. I mean, the patterns are perfectly, and they're never ending. There's no, the fact that we have these patterns is amazing, right? Not just that we have the patterns and they're never ending. Right? It'd be cool if we were in some exploding universe and we saw some random pattern, but all planets, what you call planets, what I call wandering stars, all luminaries create these patterns, right? The fixed stars just make concentric circles, but this perfection, this order, right? And this is, which one is this? I should have labeled it up here. Well, I didn't think about it. But that's certainly the sun and Earth, and I can't remember which body this is, but you can see it on YouTube if you look for it. I can't remember if it was Jupiter or Mercury. But look at these perfect patterns that never go away. Well, this, as long as we've made these observations, as long as we've been tracking the sky, they're there, and as long they'll never go away. Now this one has several, right? This one goes through several, if I remember right. Let's see. But look again. If I'm kicking a dead horse, I'm sorry, but to believe that these are just by chance, right? So many things in this world, the Fibonacci sequence, which we observe all throughout nature, these symmetrical patterns that we observe in the skies. This world was built on order, not chaos, right? Not an explosion. And these are just some of the things that came to mind. I'm sure if I had thought about it longer, maybe I would have added some more in. These certainly aren't all the dances of all the stars. I didn't put examples of the Fibonacci sequence in there in nature, the golden ratio, the fact that DNA, there's so many things you could look at that's just statistically impossible. That's proof of God. That's proof of a creator, right? And that's why flat earth is so important, is because I wasn't aware of any of this. I wasn't aware that the firmament moved as a solid piece, right? With no parallax, no movement between the stars. And that all the luminaries move like this. So what we call the planets move like this. There's so many things I was completely ignorant of. And if you start looking into it, it'll prove to you there's a creator. I think there's a quote, I can't remember the scientist, but he says, a little bit of science will take you away from God, but a lot of science will bring you to God, will bring you back to God, right? That's a great quote that I probably butchered. But hope everyone enjoyed this. Just something I wanted to get out. Again, the celestial clock is one of my favorites. Like that for me was, when I sat and looked at the accuracy, all that was certainly all the proof I needed of a creator. So until next time, take care.